Hey everybody! So with the second video we're gonna go with my second Kotlin favorite feature, which is immutability and the way you kind of declare variables as opposed to Java. So we're gonna look at a very brief example and hopefully I will be able to demonstrate you why I prefer Kotlin's approach to declaring variables and using variables in general when it comes to immutability and mutability. So let's look at a very simple example. So what do we have here? Well, it's a main function. And well, I think everybody's familiar like how you actually declare variables in Java. So let's see, I want to do like a list. So I can do something like this. And as you can see, this is very straightforward, and you basically have a list which you can do operations with. But so the way you declare variables by default is just you declare the type. Depending on your Java version, you can also use the variable keyword. But for now, let's stay with this. And what this tells you, or what this means in Java, is that, hey, you have an object, feel free to do whatever you want with this because it's mutable by default. So I can do next line like list of hey, and there is no problem whatsoever with this. So if I want to compile this, if you work with Java, well, this is just gonna work out of the box. But what I actually want to rather talk about is that what options do we have in Java for making sure something is actually mutable? Well, I can do something like this, and immediately you can see that the compiler is actually saying like, hey, you cannot assign a value to a final variable, because final in this context means that this variable, or let's say reference, cannot be reassigned, right? Once you set it, you cannot reassign it. And usually it's a good practice to do things like this, is just make code much more readable and less error prone. So it's very good, but similar to my previous video where I was sort of saying that the problem with Java's optional type is that using it is optional. Most people simply just forgot to declare final, and then you will see the same kind of problems which will cause issues. So that's one of the ways you can deal with immutability in Java. Again, if you want to prevent, reassigning something, you just basically use the final keyword. But that doesn't really solve all the problems, because now, even if I say something like this, it's the reference, like you cannot reassign the reference, but the underlying object which it points to is actually still mutable. What do I mean by that? Well, you can see something like, hey, add me, or like add this object, and then immediately, well, spoiler alert, so this is actually not what I wanted to say, but since this is a list, and if I check the list declarations, as you can see, there is the add methods. There are a couple of different definitions here, but the point is that there is an add method. Now already IntelliJ, this says a warning, this is like an immutable object is being modified. How do you do that? Well, let's run and see. And this is going to be my second issue with how you can achieve immutability with Java. So, as you can see, we have an exception, which is unsupported operation exception. And oh my God, how can this be? Well, if we look at the declaration, or rather like what this will return, as you can see, this is an immutable collection. And what this means is that if I go to the end of it, this will, whatever, depending on your GDK, return something like this. Long story short, there is no, yes, so if you see the declaration, this is like this abstract immutable collection overrides the add method, and it's going to throw an unsupported operation exception. So that's good. Now you have an immutable, some sort of immutable control, but you just by reading the code and reading the interface, again, just remember, the interface itself still has this method. I mean, of course it has, otherwise this code wouldn't have compiled. During runtime, you will be able to know that this is immutable. And again, not all lists are immutable. So if I go with something like this, so new array list, and then this now will compile because array list in itself is mutable. But what most people prefer nowadays, for many reasons, is immutability. It makes your code much less error prone. So you can see that this is possible in Java, but it's not that straightforward. The language by itself doesn't really warn you when you're using an object in a way that it's not supposed to be used. Just remember the unsupported operation exception. So let's actually see another example, which is Kotlin. So if I go here and open the Kotlin example, let's try to do the same thing, or rather just show how Kotlin is different from Java. Again, if I want to declare a list, I'm going to do the same thing, but it's going to be a bit different. So let's go with list. And what do we have here? It's a bit different because now there is no type declaration here. It's actually very similar to the var variable in Java, but again, it's inferred. So I could write something like this, but this is, again, redundant because the compiler is able to infer the type based on the definition here. So that's one thing. But what is this val keyword? Well, the val is essentially the same thing as with final in Java, but the most important thing is that final was something as an optional in the declaration. However, in Kotlin, you need to decide. There is no such thing as list. You now need to either declare this as val, which is essentially final, so it's immutable. You cannot assign this to something else. It's already complaining like, hey, this cannot be reassigned. Or if you don't want to go with immutable, you have the other option, which is var, which is, by the way, the general, or like the Java, let's say the behaviors. If I do something like this is essentially the same with var. And what are the cool things? So you already seen the previous example is that you cannot do list equals list of something else. So you cannot reassign this reference. However, if you declare this as a var, you're still able to. And the second thing is with collections and how collections handle immutability. So let's see if I can add something to this list. And already you can see that we cannot really add this because Kotlin by default gives you collections which are immutable. Because if I look at the list here, like this is, again, this is not to be confused with the GDK, because this is in Kotlin.collections. But so the list, actually, if I check the declarations, you are not gonna see anything about adding, because again, by default, we are immutable. If you want to do, and again, you cannot do the same mistake with Java. Again, the problem with Java, if I when I used this way of doing, again, IntelliJ is smart enough to complain that, hey, you're adding you're using a method which is most likely to throw some sort of exception. If you're using an editor which is not smart enough, you're going to run into the same problems. And again, it's not the editor that needs to warn you, it's the compiler. But in Kotlin, you cannot even do this mistake, which is quite cool. If you want to do, if you want to work with a mutable collection, you always need to define, like, all of these utility methods have a mutable pair. So now I have mutable list of, and now the error message is different. It's basically just tells me that, hey, you actually need to pass an actual object. So if I do this and then I go print line, obviously we're gonna see that it has 4 elements, which is really, really nice. And I think with that, we sort of covered the second one, which is immutability. Last but not least, like, how does this work? So again, this returns a list of string, or actually that's not true, because now it's a mutable list. All right, and if I check the mutable list definition, you can see that it extends the list interface where it gets these by default these methods. Makes sense. And it also extends the mutable collection, where you can see Where is this? There we go, mutable collection, where, as you would expect, you get the operations to add, remove, or manipulate the items in the collection. So that's it. That was the second best thing about Kotlin, in my perspective. Again, the way you declare objects or variables in Java is it's optional to mark them as whether these are immutable or mutable. By default, they are mutable, which makes error-prone code. And not just error-prone. I mean, last example. I'm pretty sure most of you know this, but so if I were to write something like this, and I think by default, yeah, this is the definition you're going to get. You could do something like, I don't know, new array list, and then list.add hello. And if you're new to Java, you might think that what's happening here is that, you're actually modifying the past list, because, I mean, you can still do this operation, but of course, this is not what's happening, because if I run this, the output is still going to be 1, 2, 3. And again, this is because how Java basically passes objects to methods, so everything is essentially a copy. So you're not really modifying, when you're saying like list, new arrow list, actually you're modifying this copied value, which were copied by this. But again, you're modifying the copy and not the original. So it won't have any effect on the original value. If you want to defend this, you can do final, which is just going to make your code less error prone, I suppose. But again, the final keyword is optional, which means that by default, everything is mutable, which leads to more error-prone code. Whereas in Kotlin, just like with nullability, you always need to make a decision whether that variable is nullable or not, and also whether an object can be modified, reassigned, so the val versus var keyword, and also if you're using a collection, whether that collection is mutable or immutable. So that's it. Hope I was able to give you a sense of why I think this is very cool, the bigger differences. Let me know. If you enjoyed the video, please give it a like, comment if you agree, don't agree, if you want to see something else. But otherwise, have a good one. See you.